For our second lesson in physics, we'll be tackling fluid mechanics. It is a branch of physics that deals with study of fluids, at rest and in motion. It is used in different fields of engineering. Fluids are substances that can flow and do not maintain a fixed shape. Ideal fluids, they have no viscosity, incompressible, have uniform velocity, and no friction. However, it is only a theoretical concept used in fluid mechanics. Real fluids has infinite viscosities, non-uniform velocity distribution, compressible, and experience friction and turbulence. Density. It is a fundamental physical property of a substance that quantifies how much mass is contained in a given volume. The formula for density is density equals mass over volume. Pressure. It is a fundamental physical quantity that describes the force exerted per unit area on a surface. The SI unit of pressure is the Pascal, which is defined as 1 Newton per square meter. And the formula for pressure is pressure equals density times gravity times height. Viscosity. It is a fundamental physical property of fluids that describes the resistance to flow or deformation. Buoyancy. It is the upward force exerted by a fluid that opposes the weight of an immersed object. Specific gravity. It compares the density of a substance to the density of a reference substance, which is usually water. Mass flow rate. A measure of the mass of fluid passing through a specific point in a system per unit time. Volumetric flow rate. It is a fundamental concept in fluid dynamics that quantifies the volume of fluid passing through a given cross-sectional area per unit time. It measures how much fluid is flowing in a system. Before starting with solving the practice problems, let's first discuss the formulas of density and specific gravity. Density has a formula of m over v where m is mass and v is volume. For specific gravity, we have the formula density of fluid or substance over the density of water. Always remember that the density of water is 1000 kg per meter cube at exactly 4 degrees Celsius. If the computed value of the specific gravity is greater than 1, the object will sink. For our first practice problem, the mass of an object is 500 grams and its volume is 0.25 meter cube. Calculate the density of the object. For our mass, we have 500 grams, which we will convert to kilogram by dividing 500 by 1000. This results in 0.5 kilograms. For our volume, we have 0.25 meter cube. We need to solve for the density of the object. The formula for this is mass over volume. So, 0.5 kilograms over 0.25 meter cube. The answer to this will be 2 kilogram per meter cube. Next, the density of a substance is 800 kg per meter cube and its volume is 0.4 meter cube. Calculate the mass of the substance. So our density is 800 kg per meter cube and our volume is 0.4 meter cube. We need to calculate for the mass. We can solve for mass by rearranging the density formula by multiplying both sides by volume. This results in mass equals density times volume. So, 800 kg per meter cube times 0.4 meter cube. The answer to this will be 320 kilograms. The meter cube would be cancelled. Next, the specific gravity of a liquid is 0.85. Find its density. Since our specific gravity is 0.85 and the density of water is 1000 kg per meter cube, we need to find the density of the liquid. To do this, we can just rearrange the formula of specific gravity by multiplying both sides of the equation by the density of water, which results in the density of the liquid equals specific gravity times density of water. So it is 0.85 times 1000 kg per meter cube, and the answer to this will be 850 kg per meter cube. This is the density of the liquid. For our last problem, the density of a substance is 1200 kg per meter cube. Calculate the specific gravity of this substance. So the density of the substance is 1200 kg per meter cube, and for water, we have 1000 kg per meter cube. To find out the specific gravity, we just plug in these values. So, the density of the substance over the density of water, which is 1200 kg per meter cube over 1000 kg per meter cube. The answer to this would be 1.2. And since 1.2 is greater than 1, the object will sink in water.